First law we are looking at is the Boyle's law. And the Boyle's law is a relationship between pressure and volume while keeping a variable temperature constant. So T is held constant. This law is trying to know the relationship between pressure and volume. When we increase pressure, what happens to the volume? Or let's say when the volume is increased, what happens to the pressure? And when the volume is decreased, what happens to the pressure? And so that relationship is what Boyle's law talks about. And Boyle's law states that at constant temperature, the volume of a fixed mass of a gas the volume of a fixed mass of a gas is inversely proportional to the pressure applied. At constant temperature, the volume of a fixed mass of a gas is inversely proportional to the pressure applied. And so when volume is increased, pressure decreases. When volume is decreased, pressure increases. And so for the setup here, as the volume is decreased from this to that, the pressure of the gas molecules become high. Why? As we press down, decreasing volume, the molecules are now colliding with themselves and with the walls of the container at a very fast rate, at a very high rate, and therefore the force acting on that area has increased, and that will constitute an increase in pressure. If we bring the bar down to the top as it was, you will see that now volume has increased. Coming back to this one, volume has increased, and therefore pressure will be decreasing. The pressure of the molecules in the container on themselves and the walls of the container will be decreasing. And so volume is inversely proportional to P, and V is equal to K over P, removing the inverse proportionality from there. So we can have K to be equal to PV. And if you want to consider the initial parameters and then the final parameters, let's say this is P1 and this is V1 and this is P2 and V2, then we can have a relationship that is P1 V1 is equal to P2 V2, from the fact that K is equal to P can be P1 V1 and K is equal to P2 V2 can be seen for both scenarios, and when we put it together, we're going to have P1 V1 equal to P2 V2. So this is a relationship that we have that is used to calculate for initial pressure, initial volume, final pressure, and probably final volume. Once we make any of them the subject of the equation, we can, based on the question, look for what we are supposed to calculate for. And so P1 is the initial pressure, V1 is the initial volume, P2 is the final pressure, and V2 is the final volume. If we plot a graph of pressure against or volume against pressure, we are going to see that as volume is decreasing, pressure will be increasing. However, if we alter one of the parameters, like saying that, okay, now let's make an inverse of P, that one we get a straight line. This stands to reason that if you plot a graph of V against 1 over P, you're going to have a straight line with a slope that is equal to the constant of proportionality. Now, when you plot a graph of V against 1 over P, looking at this relationship that is here, we can see that yes, the slope is going to be the constant of proportionality, because our diagram is going to be a straight line. The graph that we have will be a straight line. So Boyle's law is a pressure and volume relationship, while we keep temperature constant, and at constant temperature the volume of a fixed mass of a gas is inversely proportional to the pressure applied. And so this relationship that we have there, or this relation, will help us calculate for anything that we will need to calculate in this equation. P1 V1 is equal to P2 V2. Now let's move on and see how we are going to apply this equation to solve Boyle's law problems. Let's look at this question. A gas has a volume of 250 centimeters cube at a pressure of 100 kilopascal. What will be its volume if the pressure is increased to 125 kilopascal, keeping temperature constant? So how do we solve this? We just need to know the thing that has been given to in the equation. We have a value that has centimeters cube as its units and a value that has kilopascal as its units. We know that centimeters cube is for volume, while kilopascal is for pressure. A gas has a volume of 250, so it means that your V1 is 250 centimeters cube, and your P1, that's the initial pressure, is 100 kilopascal. Now, what will be its volume? What will be means that we are looking for V2 if the pressure is increased to 125 kilopascal. So P2 is equal to 125 kilopascal. We don't know the volume. Now, from our relationship that we have, we will see that P1 V1 is equal to P2 V2, and so we just fix in the parameters or the values, and we will have 100 kilopascal times 250 cm cube equal to 125 kilopascal times V2, and so 100 kilopascal times 250 equal to 125 kilopascal times V2. When you make V2 the subjects, you have 100 kilopascal times 250 centimeters cube over 125 kilopascal. The kilopascal cancels out. We compute 100 times 250 divided by 125, and we have our answer to be 200. Since we are talking about volume and the only unit that is left in this equation is centimeters cube, our unit is 200 cm cube. So you need to know the values well, know which one is your V1, which one is your V2, which one is your P1, which one is your P2. Once you are able to identify them, you know which one you are supposed to look for and which one has been given to you in the question. That's our first example that we have on the Boyles law. Another example that we can look at is this one. A cylinder contains a gas at 500 cm3 and 200 kPa. What pressure will compress the gas to 250 cm3? What pressure will compress the gas to 250 cm3? Like the first one, we need to know our initial volume, final volume, whatever we need to look for. So a cylinder contains a gas at 500 cm3, means that V1 is equal to 500 cm3. Your P1 is equal to 200 kPa. What pressure will compress the gas? What pressure? So P2 is something we don't know. 2, that's V2, 250 cm3. Now our relationship or our relation is P1 V1 equal to P2 V2. And so if you want to find the P2, the first one you put in the equation first before finding P2. But we can also make first the P2 the subject of the equation, P1 V1 over V2. You just have to divide through by P2. We cancel V2, sorry, then you cancel out to get your P2 equal to P1 V1 over V2. So if we put in the parameters or the figures, we can have 200 kPa times our V1 500 centimeters divided by our V2 250 centimeters. And so when we solve that, we cancel the centimeters cube out. Since you are looking for pressure, the only unit that we will have is the kilopascal. So 200 times 500 divided by 250, that will give us 400 kilopascal as our pressure.